Question 51, we've got a constant acceleration, a constant deceleration in this case. So we're looking at a Suva equation question. For part A, it says we start with the speed of u is 18. Don't really care what happens at v, but we know the acceleration A. We know the acceleration is -3. -3 because it's decelerating. S, the distance, well, the distance through to A is 48, so S is 48. And T is the time, so that's what we're looking for, so we'll put that in there. So we've got an S equals ut plus half at squared here. Let's put the 48 in, equals 18t plus, minus I suppose, minus 3/2 t squared. If I drag that all over to one side, I can get my quadratic here. And I'm just going to solve that on my calculator, and it gives me 2 times. It gives me t equals 4 and t equals 8. And you might think for a minute that you don't like 2 times there, but then go back to the question, it says times, plural. And then try and think what's happening here. Is that we've got something here, it's going off in this direction here, but of course it's decelerating all the time. So as it decelerated so far, it then starts going back on itself. And so A is somewhere over here, and we're saying that when it's at A, it's at 4 seconds, and it's also at 8 seconds. Well, for part B, we've got the same setup material. Don't care what V is again this time. A is -3, and this time I want it to get all the way back to the start again. So this time I want S equals 0. And so I've got 0 equals, well, actually it's exactly the same thing as we had before. And solving that quadratic gives us t equals 0, or the one we want, the time it takes, is t equals 12. And just spending a tiny bit more time thinking about that, that means it gets to here in 4 seconds, it gets to there in 8. So clearly the turnaround point is halfway between those. 6 seconds out, 6 seconds back, grand total 12 seconds.